Well, I guess it's a good introduction. So maybe, guys, something that we can do is first go inside the use case, the case study, because we have a lot of things to show you. If we have enough time, we can maybe show two different case studies, but depends on the time. And the very first one we will talk about is Artisans, which is a website which have been made that year in November. That's it, right? I guess you put it on award. Yeah, I guess it's in November. And so yeah, maybe just we will discover it in full screen, and after that, you guys can just introduce the website and tell us a lot of things about the project, right?
So maybe I can introduce Artisans, what is Artisans, and the whole process of design, of concepts, of motion design. Then we will talk about the development part. So first, Artisans is an agency with a lot of talents that working together, and they are creating some installations or film production for cultural events. And they ask us at Immersive Garden to create a website which doesn't look like the regular website we see usually for agencies, and they wanted something really abstract, because they don't need to put some corporate information or this kind of thing, because they want to communicate with their current clients. So this is why when you land on this website, it's very immersive. It's about storytelling without having too much information about the agency. Yeah, when the client contacted us, we went with one concept. Yeah. We had those three main points that we wanted to highlight on this concept. So the first point was the light. The second point was everything which is physical, because it's about installations, interactive things, etc. And the fact that it's very huge. Yeah. The fact that it's huge is because they are working worldwide, and this is when we talk about culture, we talk about different culture in the world, etc. So this was very important to have this third point, which is the world and the in French immensité. Okay. So after that, we had those all those key points that we highlighted to the client, but we also show a storyboard of how the website is working. So this is a very early stage of the concept. Yep. But you will notice that there are some similarity between the storyboard and the final website. Yep. So here you have the global concept. So you have the landing page. Then you can see that here something's happening on the when you over the line here, because you have the straight line. Then the line is becoming some lines that you can control with your mouse cursor. So I can maybe zoom a little bit more. Yeah. And that's you, Jilshan, who work on the design part and on the creative part? Yeah. Here, I have done, for example, I have done the concept, the storyboard, and the UI. Okay. Everything you see here has been done by me. Okay. So you can see here the lines in the center of the screen, and you can see the world with the pyramids that you can see on the website. That the first scene is pyramids, and you can also notice that there are some call to action, and another call to action here that you cannot see properly, but it's called something like hold or press to interact or something like that. Then we show that if you interact here, you have the scene with the ocean, for example, the moon and the ocean. It's changed. You can see whales under the sea. So it has been done really quick. So this is why this is not a very detailed storyboard, but the client understand that, and it was enough.
And every time you have that kind of freedom, to just make some draws and just imagine something without taking in account the fact that technically it's really difficult to do that, or is it something that you create with a technical team, or is it something you're just freestyle and it's okay, do whatever you want?
It really depends of the project, because here I know that what is technically possible, right? Sometimes I used to ask Matt, okay, we have a project, we have this deadline, can we do something amazing with this short amount of time?
Okay.
And Matt is making a face of, no, it's not possible. But sometimes he's like, yeah, let me try something, and he's checking from his side what is doable, what are the best options to do.
Okay.
Something with nice performance.
Yeah. Like I think Deshaun has kind of a good sense on what's possible or not, but it's always good to challenge the developers, like where we can push. Like, of course, sometimes we realize that it's totally impossible, but like it's like for me at least, like I don't want the creatives to be too limited on what they make and not think too much about the technical part. Because that will limit a little bit of the creativity, I feel like, and I think it's like in the end, for sure, you have to make some cuts to because it's totally not possible. But I think, like in general, it's always good to push like the concept and the storyboards and design. Then we have to kind of like figure out like. If it's really possible or not, or we have to find like
because you Matt, or you are the tech leader in Immersive Garden, right?
Yeah.
Okay. And how many people are working on that kind of project with you?
So for development, it's just 2.
Okay.
So it was me, as I focused more on 3D and on leading the project itself.
Okay.
And then Leo was Leo. You have to help me with his last name because I'm going to destroy it.
Okay.
But, so it's Leo
Mourer.
Leo Mourer, and he's in the chat. If you can say just a hello, Leo. It's a very, very big pleasure to welcome you in the chat. No problem.
So he focused more on the UI in general, and on the project setup.
Okay.
So that's the team. For development part.
And if we just keep focus on the creative part, maybe we will talk about that after Dilshan. But what about the 3D stuff? Do you have a 3D artist, or so how do you manage it?
It really depends on the 3D. We are used to do. Everyone is doing a bit of 3D. So for the concept part, it's okay. We can do some 3D, just to make a little prototype, and to show the client how it works. Then, if we need some heavy stuff, we need to work with a third-party agency or freelancer.
Okay.
So I'm sorry, I had a little prototype to show you that has been done in After Effects. I can just have a look to see if I still have it.
Yeah, no problem.
So you can see here there is a loader, and the immersion of the animation. Then you can also see what's happening if you scroll down. So it was enough for Matt to explore from his side some other cool things. But for the client, it was like, okay, I understand how it works. That's fine. Let's go. So after that, we needed to create all the scenes. So here, I have worked with Anaïs, who was there before. So she worked with me to find some nice scenes to recreate after that in 3D. So she worked on some models from her side. So here, as you can see, you have four scenes that we needed to mood board before doing something in 3D, because we really wanted to show the client the art direction we wanted to have, and also the different interaction we have. So here on the website, you have seen that when you click, something's happening. So to define that, we have created this mood board where you can see what's happening on the interaction 1 here. So you have the good rays. Interaction 2, you have the light on the river. And interaction 3 is fantasy pyramids.
Okay.
So this is what we show to the client, and it was also very helpful for Matthijs to try to do something directly in WebGL.
Okay.
It's always very useful to have mood boards too, because it kind of really tells you what kind of mood is wanted, and for me it really helps. Like sometimes even I do it myself to add some extra ideas to in what direction I wanna push it.
Mm-hmm.
So you can see that this is really a dashboard with a lot of comments and what we shouldn't do and what we should do, etc. So we have really used that as a reference to work on the project. So sometimes we are adding new things that are interesting and erasing other things that are not interesting enough. So you can see that for every scenes, for example, there is a scene with giant. So this is this model that we used.
Mm-hmm.
With the giant.
Yeah.
So here are the scenes, and after that we have created some 3D here, some 3D models, really draft models, just to have a look in 3D. Then those are some work in progress of the 3D. As you can see, this is this has evolved a lot.
Uh-huh.
Also, yeah, I have done a matte painting of in Photoshop of how it looks like with with the pyramids, with the lights, what's happening on the interaction. So you have the river that is appearing, and here got rays. So as you can see, even if the mood is a little bit similar to the final website, a lot of things has evolved.
Mm-hmm.
Because when Matthijs received those elements, he's also trying things from his side. And also there is an important thing is about performance in development, because
yeah, definitely.
we cannot do exactly what I suggest here, for example, but he's trying to find a way to make something as nice as this, but in a different way.
Mm-hmm.
Yeah.
So also here some some bit of so this is a 3D scene with a bit of Photoshop on it to show how it works if you click, and the same here. And here you can see some screen directly from a work in progress from Matt.
Yeah.
From the WebGL. So those are WebGL screen shots.
Okay.
Then after that we have defined the colors of the lines directly here. Then after that, we were fine-tuning some little elements.
So what you see here is a LUT or a lookup table.
Mm-hmm.
That's can you see my cursor? I think so, right?
Yeah.
Okay, so perfect. So on the bottom right, it's an image or a lookup table that I can use in the, let's say, in final pass of the post-processing.
Okay.
To create, you can kind of create like change the colors and then the moods of the original, let's say, a rendered scene. So what kind of nice about this is that so there's two ways of doing this. Nowadays you can also use 3D lookup tables. That's already something that's Photoshop. But yeah, something to do with WebGL 1 and WebGL 2. But the nice thing about this is that I can, Deschamps can make a screenshot of the scene, and I give them the lookup table. I don't know what the original one. Yeah, I don't think the original one is here. But let's say the original one looks something like this.
Okay.
He can put that on the image, and then he can change all kinds of settings, like maybe hue or contrast or brightness. And that because of the images on top of it, you can it will also update that image. Yeah, so the original one is not here, but you can see like really like a different vibe between because of that.
And I guess it's a good way to do this through a lookup table to be more performant, right?
You could do it directly in the shader if you want to, but the nice thing about this is that it's the workflow.
Okay.
Because he can just update the image, and he can even with the tool set we have, or you could even just drag and drop the image, and it will directly update the new color profile of the current scene.
Okay.
So and the nice thing is how we use it here is that we I think you see it later in my slides as well, is that you see that every scene has 3 lookup tables. What I'm doing is when the interaction is happening, I'm interpolating between the different lookup tables.
Okay.
Which totally changes the mood of the scene. And this is also being used in games and movies and this kind of things. But yeah, it gives a quite nice flexibility on changing the color profile of the whole scene.
Okay. Just a few moments. I have to explain in French because someone don't understand why the lookup table. Donc en fait le principe des lookup tables, c'est que vous utilisez une image, en fait les petits carrés que vous voyez, et en fait c'est une espèce de table de correspondance, si vous voulez, au niveau du rendu en fait final qu'il va y avoir sur l'image, et donc ça permet en fait d'appliquer une espèce de traité colorimétrique. Et donc ce qu'explique Matt, c'est qu'on peut vraiment jouer sur beaucoup de paramètres en fait grâce à ces lookup tables, agir sur le contraste, agir sur à peu près tout. Voilà, c'est exactement ce qui est dit là. C'est comme un LUT en vidéo, et c'est ce que j'expliquais. J'ai fait de la vidéo de mariage fut un temps, et donc c'est très appliqué en fait dans ce type de situation. Vous avez donc ce qu'on appelle un LUT, un lookup table, qui vous permet en fait d'avoir une colorimétrie qui est raccord en fait. Et souvent c'est utilisé dans les films de mariage parce qu'on a un certain mood à donner qu'on veut reproduire en fait dans d'autres films de mariage. Voilà pour l'explication. Okay, so switch in English. I explained just in French with my own words. So maybe you can continue.
So I will go very fast here. This is just the UI we had to do.
Okay.
So this part has been developed by Leo.
Okay.
Even if Matt was a lead developer on it, Leo has done a lot of work on the motion, little interaction you have on the cursor here, for example. So we have also defined everything, how everything works on directly on Figma.
How can you manage it? The fact that you create that kind of experiment and you are not very sure about how many time it will take, because we can see that you have specific workflow, specific process, and how is it possible to know how many days, how many time, and because at the very end you have to be paid. It's something which is a reality. Is it easy? Do you have a specific workflow to just estimate what can be the price of a project? How can you manage it?
In this kind of project, it's very difficult to define. We can just say, okay, we have maybe 5 weeks for the design, then 12 weeks for the development, and let's try to do something really cutting edge. So if you have the right persons to do that, this is not a problem.
Okay.
But it's if I can say something else, is much more about also to achieve this kind of project. You need to put your soul, your body, everything in it. You cannot do it like it's something simple. I would say it can be simple for anyone if you put a lot of passion on it.
Yeah.
it's very important because you know, it's I know that Matt was working on it. Even if we don't do you know, we don't stay after 7 p.m. because here at 7 p.m. everyone is going home, but Matt was staying here just because he wanted to improve some little details. So he had the passions to do that. And this is not maybe the time you spend. Okay, the time is very important, but this is also the energy you put on every single detail to achieve this. And this is really important to understand that it's possible for anyone if you put this energy to do something nice.
Maybe I saw a question in the chat that like what framework we're using.
Okay.
So for 3D, it is threejs. Like for this type of projects, it really makes sense to use threejs because there's a lot of things in it that are very useful. You don't really want to do that yourself if you don't have your own framework. So yeah, that's and for the rest, maybe a little bit of for the front end and for the UI, we're using Vue and Next.
Okay.
For all setup, and then I think for the rest, yeah, gsap for the animations. It can be 3D, it can be 2D, it can be everything. So it's kind of like that. Of course, we use a lot more, but that's I think the most important ones. Okay. So I will start with a little bit, yeah, maybe a little bit simpler one. It's not like it's super detailed in the, or you don't see that much in the scenes because we want to keep the birds like very subtle and not too big. So you can also see the model is quite basic, but it doesn't really matter too much because you see it from far away. So you can quite reduce the polygons. The interesting thing I wanted to share here is that on the left side you can see all the birds flying, and this will happen in one render call. So that's better for optimization than rendering every bird individually. And to animate them, what I'm doing is what I did before in Blender. Like I'm using Blender quite a lot, like for a lot of many different things. But in this case, I used the Vertex paint tool to color the vertices. Because if you export this with GLTF, then this will be exported. Like some things won't be, or if you have extra attributes on the vertices, it won't get exported, but it does for the vertex colors. So that's what you see here on the right side. So you can see the top of the tip of the wing is very red, and then when it gets closer to the middle, it gets a little bit lighter. And like I don't use this as a color, but I use this as a value to do the animation of the wings and of the tail. And then the tail is green, so I can animate that with a different offset. Okay. So this gives me the possibility to do this very easy in the Vertex shader, and with different offsets per bird to make it a little bit more natural. And then on top of that, I will move the birds, the whole position individually. And then this is just very, like it's very performant because it's just happening in the Vertex shader. Okay. Okay, so here you can, this is like a quite early prototype of the lines. An interesting thing here is that I'm using inverse kinematics to do the motion of the line themselves. And the nice thing about inverse kinematics is that you get something very like a fluid. Maybe I should explain a little bit about what inverse kinematics is. Yep. It's a bit easier to explain if I make it visual. Yeah. So if you have the forward kinematics, it's more like if you animate an arm. Okay. Then the animator will like move this part first, then moves this part, and then moves this part. So that's what's called forward kinematics. And if you reverse kinematics, is kind of the other way around. So let's say I move my hand, the rest of my arm will move with it. So which gives a lot more flexible, more natural way of animating things. That, of course, there's a lot more involved because you have to be able to kind of lock on how far some joints can move, and all this kind of things. But in this case, I use it on the line animation. So with the lines here, what I'm doing is I'm using a library for all the calculations that are happening. But here you can see the red dots are kind of the leading point of what animates the lines. And then, of course, you have some other configuration you can do to make the lines a little bit more natural. Some other interesting thing implemented here is that all the lines are also rendered at the same time. Even if the animation is a little bit different, they are still rendered at the same time. Otherwise, I have to render the line individually, and that can take a little bit more performance. If I remember correctly, what I did is to, because you see the lines, and the lines all have the bones, but because there's a lot of points, let's say, it will generate create a very natural line that's moving around. But all the positioning, I'm storing them in a texture. So that's maybe to come back what you said before. Like now, I'm storing all the position data in the individual points. I'm storing them in a texture, and that's a data texture. That's what it's called in threejs. So that's basically just, if you would look at it, it's just like an image with random colors. And I'm doing this. I'm creating this data texture on the CPU, just every frame, and then I'm uploading this texture to the GPU, and I'm reading this in the Vertex shader to do all the positioning of the individual points you see on screen. Which I can even create now with this setup, I could even create 500 lines, and it would render pretty okay for most machines. It kind of depends. You shouldn't push too far. But now this gave the flexibility to see how many lines you want to choose. And because I had to, in general, I had to optimize all the small little things because there was a lot of things happening in the scene. So that's why I chose to do it this way. So maybe I can look into that, because here you see the lines, but you're changing the whole landscape. So what you see here, for example, is that on the final website, is that you see the lines constantly moving and following the mouse and the camera, whatever. But if you change the scene, the line doesn't. You still keep seeing the line. It just changes the color. So what I did here is I'm really rendering the line to a separate layer or a separate FBO. And then, basically the lines are not really inside the scene itself, but they are let's say in a separate scene, which gives me the flexibility to change the scene in the background, but keep rendering the lines in the foreground. One of the challenges here was also because if you change scenes in the, for example, or webgl or threejs, there's a lot of things happening in the background that you don't really know of. So there was kind of a challenge, how can we keep the line as smooth as possible, but still change the scenes in the background. So there's a lot of technical things happening in the background, but some things what I did was, or what takes a lot of time is, for example, uploading textures to the GPU. So there's some different ways you can do it. You can, for example, use the basis compression or KTX2. So if you have a PNG or a JPEG, it still has to be converted to something that the GPU can read. And with the basis compression, it's something that you can almost on the fly load this texture to the GPU, and you won't have any hiccups on the CPU. Because if you use a JPEG or PNG, this will happen on the CPU, and this can give like hiccup in frame rates. So that rates quite nice to do, but yeah, it's also something what I learned in this project. You have to balance it a little bit, because of the compression. Sometimes, depending on the type of images, it really will just kind of destroy the gradients or the quality of the image.
Okay.
And there's even two different types of compression you can do on the with basis. But still, sometimes I even still have chosen to go for PNG or JPEG because the quality in the end was better.
Okay.
So, but during when I was optimizing this, in the end I realized that like uploading the textures directly was still, or during the scene change was still too slow. So in the end, I'm uploading them beforehand, before all the scenes are created. And another interesting thing is that what's quite slow is the compilation of shaders.
Okay.
So that's something with threejs you can do that, or there's already some API built into that you can precompile the shaders you're using. So I'm precompiling all the shaders beforehand. I'm doing that also in a preloader, so that takes a little bit more time, but it gives a way more fluid experience for the rest. Because if you change scenes and the shader needs to be compiled, then it can really give hiccups in the motion. And like if you normally have a scene and you go to black and you come back to the scene, then it's not really a problem because you don't have anything animating. But in this case, we had the lines on top, so that's where we had to really try to keep the performance really great to keep the fluid lines moving.
Okay.
Okay, there's another one. So this is for the forest scene. On the bottom right, you can see a little bit what's happening. This is an older version of the forest scene. It was just more during the early stage of developing the scene. But for the forest scene, we wanted to create like a nice, dense, well, as much as dense forest as we can, because that gives like that's the kind of the vibe we wanted to let the users feel. Of course, like normally, like to kind of have nice trees, it's yeah, you need quite some detail to show that. So we tried some different things, and in the end, what I ended up with is 3 different types of trees. So it's a little bit hard to see, but let's say the middle one, the white one, is like the tree the most detailed tree, and that's the one that are closest to the camera. And then like we have further from the camera, let's say on the side, we have the ones on the left in the background, which is just 2 planes with an image of the rendered tree on top of it. Because it's not really close to camera, so you can only see, you don't really see the details, but it can still give you the density of the forest. And then all the way in the back on the side, we have just a plane with different trees that I just placed in Photoshop, scaled a little bit, rotated a little bit, to kind of hide the holes all the way on the sides of the forest. Another thing I'm doing here, and that's what you maybe can see a little bit on the bottom right, like now when something is outside the camera view, or that's kind of what you decide on yourself. I'm hiding and showing the trees. So what I'm doing here is this what's being called a level of detail. So further away from the camera, I will show the simplified tree on the left, and when the trees get quite closer to the camera, I will replace it with the high detail tree. So when the users get closer to the tree, it will look more detailed. And the nice thing of it's a little bit hard to see within the scene, but even the trees are moving on with the wind, And that's, yeah, you need kind of a little bit more detailed model of a tree to do this kind of things.
Okay, is it linked with the, you know, the techniques of Frustum culling, right?
Yes, no, it's two different things. So the Frustum culling is, yeah, so it's done by threejs, the framework itself.
Okay.
But it kind of checks in what's inside the frustum of the camera, and then it shows it or hides it. So maybe this little GIF on the bottom right is a little bit confusing because it still shows stuff behind the camera, because the block you see here and the thing that's the camera view. What I'm doing here is I divided everything in let's say in parts or sections, because then I'm able to render many trees at the same time with instancing, which is also most of the time more performant. But like I could instance all the trees, but then this would be a bigger performant hit. So I divided everything in chunks, and then when the camera is far enough from the chunk, it will hide the chunk. You know, and otherwise, if it gets closer, it will show it. So that's why it's here. It's a little bit in chunks.
Okay.
So that's kind of more about Frustum culling and showing and hiding. What I was talking before is about the level of detail. So that's a different technique. So
okay.
So the level of detail is, I think that's what you mentioned before. It's more about if things are far away, you can create a different level of detail model. So less polygons, less vertices within that model, because it's far away, so you don't really see the detail. So it will be a lot more performant to render like a simple version of or in this case, a tree. And here it's like a very simple, it's just two planes with a texture on top.
Yeah.
And then at a certain point, when you get closer, then this model will gets replaced by a higher quality model, high vertices models. Here it's just two steps, but yeah, you can make as many steps as you want. So I'll go to the next one, and this is about the pyramids, because there's like a little line animation. I think the pyramids you see here is a little bit of an older version, because all the screenshots and GIFs and videos most of them is being made during development to show off to the team and to discuss about it. I want to show this one is to kind of explain on how I did the animation of the lines on the pyramid itself. So what I used is the texture on the left. And the left is just it looks kind of like an ugly image because it's something I created inside of Photoshop manually. So what I did, I used a brick texture. Or maybe I'll explain this a little bit more. You can see different colors. You have red, and it looks a little bit greenish, but it's green. And you have blue. You don't really see the blue on this screen, but here I'm using the individually color components, so RGB, to do the animation of the lines. So I'm using the red channel, the red component, for the progress of the lines. Then I'm using the green for the masking of the lines, and there's also blue, which you don't really see, but that's more kind of showing the lights that's kind of coming from the beams on the sides. So that gives like a smooth gradient from the beam to a little bit more to the center. So here I'm just using this texture to animate everything, and you can see that the lines are moving not at the same time, but they all have a different offset. And I'm just using so the Y of the UV, so then you know kind of what height it is to change the timing offset of the progress of the animation. I don't know if that's very clear, but that's kind of the general idea. Because now you're kind of flexible to do whatever with this animation and changing the time, and you don't have to draw this on a 2D canvas first and then upload it to the GPU, which is very slow. This everything happens on the in the fragment shader.
Okay.
And I'm also using this texture also as a mask for creating the glow, like to have the bloom effect. So I'm using this in different steps, like to really render the color, but also as a mask for something that has to glow or not.
Okay.
So the scan effect here is there was something really important to like illuminate the world and change the world and activate all the different elements that changes. What I'm doing here is this is actually be done in the final pass of this is done in post processing. So it's not directly on the models itself, but it's I'm using the depth buffer. So that's what you see on the left side. So I'm rendering. This is kind of this is something you can define, and this is what you get. Like here is just a representation of white and black, or and in between. Mm-hmm. But with this information, I can retrieve the world position, let's say of that pixel, and with this information, I can use to create this scan effect you see on the right. So it's not done individually per model, but it's just in general on top of the whole scene with the depth buffer. Yeah, that's it. It looks really in 3D, but it's really it's done in kind of in 2D.
Okay, and this is the same way to manage it through all the different chapters of the website, right?
So the scan effect, yeah, this is exactly the same everywhere, because you just get the depth information per scene, and then you can use that to create the effect on the right side.
Okay.
So I will skip this one. I would like to show only this one because I think it's kind of interesting. It's a little bit similar to what you have seen before. Is that so to create the bottom right is the final image, mm-hmm. And that's kind of you have like the fog and kind of the fog in the background. And to create this effect, I'm using a technique it's called SSMS, or screen space multiple scattering. To explain it very basically is on the top left you see the normal rendered scene. On the bottom left there's like a big I'm glowing the scene with the bloom or the Unreal Bloom post-processing effect. That's already an example of threejs. And then using the depth buffer on the top right. I know how deep it is, and then I can interpolate between both of the textures, and then you can create like this very like foggy, but also it's mixing the background with the fog at the end of the mountains, or depending on the depth of the camera. Okay. Which normally you can also just use the fog of threejs, the standard, the expansional, or the linear, but this will just just grow to, or should go to one color, and this really kind of mixes up the mountains with the color that's around it, which what I think creates like a nice atmospheric effect, and maybe a little bit more realistic in the end.
Mm-hmm. And you can fine tune your fog more than the traditional one, right?
Yeah, I'm also using like it's a big mix of everything. So I'm using there's also other technique I implemented. It's more to implement a ground fog. That's something that's another technique of doing this, which creates like a very foggy effect on the ground. But you need models to do that, because to create this effect, you need to be able to modify something that's visible and kind of create that effect. But if you would use here the normal linear fog in the traditional way, then it wouldn't mix up with the background. So let's say you go to gray, then you would see the mountain in the background in the gray, but then around it, the cube map will be color, so it doesn't mix up. And with this technique, you get this really nice mix of both both of the background and of the foreground.
Okay, makes sense.
So
Okay.
I think that's Tobias talked about it already, and we have some part to do there.
The best part.
Yeah, I think that's it. Yeah. So for the rest, let's quit here. So I will switch back to the camera.